Today should be a little bit of a review. We're going to talk law of sines. Typically, law of sines is used to find unknown values of triangles, be it sides or angles. So you'll see in this case, I have a triangle that's not right, and we want to find a missing side. And I can't really do that using right triangle trig again because it's not a right triangle. What I could do is I could drop an altitude here, find this side, call it y. Once I have y, find this z, and then once I have z, I could use that to find x. But that's 3 steps. Now, the law of sines states, and I'm not going to go through and derive this again because you should have done that last year. The law of sines states that if I have a ratio of a side over the sine of its opposite angle, that's equal to every other ratio of a side and its opposite sine value of the angle. And I could do the reciprocals of that as well. So take the sine of an angle over its opposite side and set that equal to all the other ratios of the sines of the angles and their opposite sides. We want to do this given 2 angles and a side, or 2 sides and an angle. So in this case, you'll notice I have 2 angles and a side, so I want to use the law of sines. I'm looking for x, so that side over the sine of its opposite angle is equal to another side, 8, over the sine of its opposite angle. And then all I have to do is multiply by sine of 55, so I have 8 sine 55 over the sine of 26, and that's going to equal x. And remember, once again, we want to be in degree mode, so we get roughly 14.95 as our value for x. Now, they ask us in this next example to solve the triangle ABC. When they ask you to solve a triangle, it means find all missing sides and all missing angles. So let's draw our triangle first. Angle A is 40 degrees. Angle B is 80 degrees. Let's call this 80. And side C, which is going to be opposite angle C, is 16. So you'll notice in this case that I have a side sandwiched between 2 angles, and this wasn't one of the cases we had to use our law of sines. However, since I have 2 angles, I automatically have the third because we know the sum of the angles in a triangle is 180 degrees. So far I've got 120 used, so I must have a total of 60 left for C. Now I have 2 angles and a side which I can use, and we'll use the law of sines once again. So I'll take 16, put that over the sine of 60, and set that equal to, let's call it the side A over the sine of the angle A, which is 40 degrees. So this gets me A will equal 16 sine 40 over sine 60. Likewise, I can do the same for side B, just set 16 over sine 60 equal to B over the sine of 80 degrees, and thus 16 sine of 80 degrees over sine 60 equals B. So in this case we have values of A equaling 11.88 and B equaling 18.19, and we already said angle C was equal to 60 degrees, so the triangle is now solved. Let's take a look at a word problem. We've got two cables of 300 and 270 extended from the top of a television antenna. So here's the television antenna, and these cables go on opposite sides of the antenna, like so. We have 300 on one, 270 on another, and the longer cable, which is a 300-foot cable, makes an angle of 48. Let's assume this antenna is perpendicular to the ground, and we want to find the acute angle that the shorter cable makes, so let's call this X with the ground. Here are my two answers, so we're going to be working towards these two, and then we're going to find out how far apart those guys are. So I can find X pretty easily, since this is a side followed by a side followed by an angle, two sides and an angle. I can use my law of sines and say, well, if I want to find X, I take the sine of X over 300 is equal to the sine of 48 over 270. So I have the sine of X equals 300 sine 48 over 270. X will then equal the inverse sine of whatever 300 sine 48 over 270 is. And remember, we're going to be in degree mode when we do that. And that's going to get us approximately 55.66 degrees. So that's this guy right here. Given that, I know that this other angle all the way across here, since they all add to 180 degrees, must be 76.34. And that means I can find this distance over here, let's call it y, by just saying y over the sine of 76.34 is equal to 270 over the sine of 48. I like to use the exact values, not the calculated approximations. So in this case, y will equal 270 times the sine of 76.34 over the sine of 48. And like our initial answers told us, this is about 353.04. So there we have it. And that's all we've got today. Do your lesson summary, fill out your My Math Lab. We'll see you tomorrow.